Our Earth's upper atmosphere is cooling and contracting due to climate change. And this is what the NASA satellites are viewing. This is by NASA Goddard Space Flight Center, Lena Tran. The sky is not falling, but scientists have found that parts of the upper atmosphere are gradually contracting in response to rising human-made greenhouse gas emissions. Combined data from 3 NASA satellites produced a long-term record that reveals the mesosphere, the layer of atmosphere 30 to 50 miles above our surface, is cooling and contracting. Scientists have long predicted this effect of human-driven climate change, but it has been difficult to observe the trends over time. You need several decades to get a handle on these trends and isolate what's happening due to greenhouse gas emissions, solar cycle changes, so it's the sun's activity, of course, as well, and other effects, said Scott Bailey, an atmospheric scientist at Virginia Tech in Blacksburg, the lead author of the study, published in the Journal of Atmospheric Solar Terrestrial Physics. He said, "We had to put together 3 satellites worth of data. Together, the satellites provided about 30 years of observations, indicating that the summer mesosphere over Earth's poles is cooling 4 to 5 degrees Fahrenheit and contracting 500 to 650 feet every 10 years. Without changes in human carbon dioxide emissions, the researchers expect these rates to continue. Since the mesosphere is much thinner than the part of the atmosphere we live in, the impacts of increasing greenhouse gases such as carbon dioxide differ from the warming we experience at the surface. One researcher compared where we live, the troposphere, to a thick quilt." Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. "Down near the Earth's surface, the atmosphere is thick," said James Russell, a study co-author and atmospheric scientist at Hampton University, Virginia. He said, "Carbon dioxide traps heat just like the quilt traps your body heat and keeps you warm. In the lower atmosphere, there are plenty of molecules in close proximity, and they easily trap and transfer Earth's heat between each other, maintaining that quilt-like warmth," he said. "That means little of Earth's heat makes it to the higher, thinner mesosphere. There, molecules are fewer and far between. Since carbon dioxide also efficiently emits heat, any heat captured by carbon dioxide sooner escapes to space than it finds another molecule to absorb it. As a result, an increase in greenhouse gases like carbon dioxide means more heat is lost to space, and the upper atmosphere cools. When air cools, it contracts, the same way a balloon shrinks if you put it in the freezer. This cooling and contracting did not come as a surprise. For years, models have been showing this effect," said Brentha Thuriraja, a Virginia Tech atmospheric scientist who contributed to the study. And the scientist said it would have been weirder if our analysis of the data did not show this. While previous studies have observed this cooling, none have used the data record of this length to show the upper atmosphere contracting. The researchers say these new results boost their confidence in our ability to model the upper atmosphere's complicated changes. The team analyzed how temperature and pressure changed over 29 years using all 3 data sets, which covered the summer skies of the North and South poles. They examined the stretch of sky 30 to 60 miles above the surface. At most altitudes, the mesosphere cooled as carbon dioxide increased. That effect meant that the height of any given atmospheric pressure fell as the air cooled. In other words, the mesosphere was contracting. Earth's middle atmosphere, though what happens in the mesosphere does not directly impact humans, the region is an important one. The upper boundary of the mesosphere, about 50 miles above the Earth, is where the coolest atmospheric temperatures are found. It's also where the neutral atmosphere begins transitioning to the tenuous electrically charged gases of the ionosphere. Even higher up, 150 miles above the surface, atmospheric gases cause satellite drag, the friction that tugs satellites out of orbit. Satellite drag also helps clear space junk. When the mesosphere contracts, the rest of the upper atmosphere above sinks with it. And as the atmosphere contracts, satellite drag may wane, interfering less with operational satellites, but also leaving more space junk in low Earth orbit. The mesosphere is also known for its brilliant blue ice clouds. They're called Noctilucent or polar mesospheric clouds, so named because they live in the mesosphere and tend to huddle around the north and south poles. The clouds form in summer when the mesosphere has all three ingredients to produce the clouds: water vapor, very cold temperatures, and dust from meteors that burn up in this part of the atmosphere. Noctilucent clouds were spotted over northern Canada, May 20th, kicking off the start of the Northern Hemisphere's noctilucent cloud season. And here we have the NASA images of noctilucent clouds over the North Pole. Now, because the clouds are sensitive to temperature and water vapor, they're a useful signal of change in the mesosphere. We understand the physics of these clouds, Bailey said. In recent decades, the clouds have drawn scientists' attention because they're behaving very oddly. They're getting brighter, drifting farther from the poles, and appearing earlier than usual, and there seems to be more of them than in past years. The only way you would expect them to change this way is if the temperature is getting colder and water vapor is increasing, Russell said. Colder temperatures and abundant water vapor are both linked with climate change in the upper atmosphere. Currently, Russell serves as principal investigator for AIM, short for Aeronomy of Ice in the Mesosphere, the newest satellite of the three that contributed data to the study. Russell has served as a leader on all three NASA missions: AIM, the instrument SABRE and Timed, Thermal, Ionosphere, Mesosphere, Energetics and Dynamics, timed for short, and the instrument HALOE, HALOE, on the since retired UARS, Upper Atmosphere Research Satellite. Tamed and AIM launched in 2001 and 2007, timed, respectively, and both are still operating. The UARS mission ran from 1991 to 2005. Russell said, "I always had in my mind that we would be able to put them together in a long-term change study. The study," he says, "demonstrates the importance of long-term space-based observations across the globe." In the future, the researchers expect more striking displays of noctilucent clouds that stray farther from the poles. Because this analysis focused on the poles at summertime, Bailey said he plans to examine these effects over longer periods of time and, following the clouds, study a wider stretch of the atmosphere. This is by NASA Goddard Space Flight Center. Lena Tran on phys.org. Please leave your comments and thank you for your support.